Hello, my name is Stephanie McAdams, and this is my protein. I was given the 1,5 biphosphate carboxylase oxygenase. All right, so first we're going to start out with what is a protein. A protein contributes to every aspect of every living being's existence. Proteins are made up of a mixture of 20 different amino acids, each unique to the specific protein. And this unique pattern makes up its primary structure. The second structure is going to be whenever beta sheets and the alpha helixes come together. And then tertiary structures is when a protein will start getting its full 3D structure. So finally, a quaternary structure. This is whenever two polypeptide chains come together to create this huge 3D model. After just a very basic rundown of proteins, I'm going to move on to mine. Mine is rubisco, or the 1,5 biphosphate carboxylase oxygenase. So this is a major enzyme that starts off the photosynthesis and Calvin cycle with C3 plants. This enzyme is able to take the CO2 from the air and attach it to a 5-carbon sugar chain, and this creates an organic carbon, and this whole process is called carbon fixation. Rubisco, it's a very, very slow enzyme. A lot of enzymes can do about 106 to 107 reactions per second, but Rubisco can only do 3. So this makes the plant makes up for this by creating just so much Rubisco, and this is the most abundant enzyme that's been ever made. Rubisco, it's not the best. It's able to be easily confused oxygen for carbon, and whenever this is done, it'll attach the oxygen to our 5-carbon chain, the sugar chain, and this will make a very toxic enzyme to the plant, which the plant must take a lot of time and energy to undo. If not, it could cause plant death. So Rubisco's structure, scientists have finally found a way to map the entire structure down to the atoms in it. So they have a complete 3D model of it. They found out that it's made of 8 small and 8 large polypeptide chains, and it has a 4-stranded beta sheets with flanking alpha helixes, which make up a quaternary structure. So because Rubisco is found in every C3 plant because of photosynthesis, there's some different variations of Rubisco which can be found. So scientists have started experimenting with this protein to find a way to bypass the enzyme entirely, or to help the plant type detoxify whenever Rubisco makes the mistake of attaching an oxygen to the sugar chain instead of the carbon. So they tested this where they injected the plant with cyanobacteria, and they have tested in tobacco plants where they saw a 40% increase of growth over the untested plants. So they are going to continue to experiment with other staple crops like corn and the black-eyed peas. So in conclusion, Rubisco, it has been believed to have evolved from Earth's atmosphere whenever it started changing, like 3 billion years ago, whenever oxygen had started to come in, and plants had to evolve. So scientists are believing this is why there's issues with Rubisco and why it's so slow and has it's like chain issues. So that's why they're trying to figure out how to bypass that. But now that we have a full map of the enzyme, scientists believe that they're finding better ways to help the plant with the carbon fixation. Thank you.